Alright class, it's week number 27 and lecture number 157, and in this week we are going to revise the past papers of the topic transformation. So before starting the past papers, let me just give you a quick revision regarding the topic transformation. So in that topic we had discussed mainly 4 transformations in which we had discussed about the translation, reflection, rotation, and the last one is enlargement. Now in these 3 transformations which we call isometric, is that no change in size. Whatever the size of the object will be same as the size of the image. But in enlargement, that is non-isometric, it is in this transformation there is a variation in size. So I am saying that size varies, right? So that is the basic difference between these 3 and enlargement. Now, if I discussed one by one individually, so what we had discussed in translation is that the concept of push an object or pull an object, right? Remember that. Let's suppose if a point, this is a point, you had moved it 2 units on the right, so it will be at new place, right? So in generally we had discussed in this form that object plus translation vector is equals to image or new point. That is a basic understanding that we had developed during the topic translation. When we had discussed about the reflection, so there are 4 subcategories we had discussed. It's reflection in the x-axis, reflection in the y-axis, reflection in the line y equals to x, and reflection in the line y equals to minus x, right? And what happened actually, let's suppose that you have a point here, right? This is your point A and the coordinates are 3, 1. So when you reflect your point across the x-axis, so this point A dash, it will be 3 and minus 1, right? When you shift or reflect this point A against y-axis, so that will be A minus 3, 1, right? So these are the things that we had discussed in reflection, and I told you there is a short technique regarding the reflection. If it's an x-axis, so you say that xy swept onto x and negative y. If it's in y-axis, xy is swept onto minus xy. If it's in the line xy, so x and y swap their position, and if it's in the line y equals to minus x, so x and y swap their position and their signs. Alright? Similarly for rotation, we had discussed that there are either 90-degree clockwise, 90-degree anti-clockwise, and 180-degree, right? The second most important thing in the rotation is center of rotation, right? We had discussed in detail when we had discussed the topic rotation that how to find center of rotation. So generally, if I need to revise a little bit here, so let's suppose that you have a triangle x, y, z, which is after rotated lies here, right? that is x dash, y dash, z dash. To find out the center of rotation, first we need to join the corresponding points. So I combined x and x dash. Now you need to draw the perpendicular bisector. We had discussed in locus how to draw the perpendicular bisector. That is your first red is your important line. Similarly, I will combine another point. So I will combine y and y dash, and I will draw the bisector of y and y dash. That will be like this, right? The point where these two bisectors meet is your center of rotation. So that's how you find out the center of rotation, right? And the last one is enlargement. Now enlargement, we had discussed about the scale factor, which referred by the alphabet k, and we had discussed that how to find k. K is basically the ratio between the new length and the original length. Also we had discussed that if k lies between 0 and 1, then it will be a contraction, or you say that it is a reduction in size. Apart from the value from 0 to 1, we never have the smaller image. Negative sign indicates inverted image, right? Negative indicates inverted image. And what does it mean? Let's suppose you have a triangle A. If A is enlarged, so that will be enlarged triangle with a positive scale factor, right? Scale factor is positive in this case. For a negative scale factor, it will be plotted like this. So these are the important points that you should be recalling while doing the topic transformation from the past papers, right? So if there is a need to write down all the things, if you have a time, you can note it down. All right? Or you have all those things written in your lecture copy if you had note down all the important things when we were discussing the topic transformation. Now I'm going to start the past paper question, and I will give you the time because I just give you a small and quick revision. So I will give you first time to try it by yourself, but before that, try your best to bring out that question, right? It's June 15 paper 2 and question number 10 part A. It will be very beneficial for you if you just print out that question paper, or if you can solve it on the past papers. So it will be very beneficial as compared to if you just watch the video. So for every question, for every part, I will give you the time first and then I will start. So it says, describe the single transformation that maps triangle A onto triangle B. So if you had observed the triangle A is transformed onto triangle B, what do you think that which type of transformation it is? And whatever the transformation it is, let's suppose you had think that it's a reflection. So you need to define reflection completely, that in which line it is reflecting, or if you say that it is a rotation, then you need to define rotation completely, then which what is the angle, what is the direction, and what is the center of rotation. So you need to describe your transformation completely. And for the first part, let me check its weightage. It's a 2 mark. So for the first part, I will give you the time of 2.5 minutes. All right. First, try it by yourself, and then I will start. All right. So triangle A is transformed onto triangle B. So that is our rotation. At first, it's a rotation. Direction is what? It's 90 degree and it's anti-clockwise, right? Now the last important thing that I need to highlight here, it's center of rotation. Now what is the center of rotation? So let's suppose roughly if I told you that is point X, Y and Z after rotation, that is X dash, Y dash and Z dash, right? Now I need to combine the corresponding points, so I will need X and X dash. You need to do it with your pencil and scale because I'm just sketching roughly. Now I need to draw the perpendicular bisector. So 1, 2, 3, 4, 5, 6. That means 3. 1, 2, 3. So the perpendicular bisector of this line would be like this, right? Similarly, if I drawing another line, let's suppose Z and Z dash, and then I need to draw the perpendicular bisector. So it's 1, 2, 3, 1 and 1.5. So that is a case of drawing the perpendicular bisector. You do it by your scale, pencil and compass, so you will get the correct value, right? So I'm just rubbing it now. I'm just rubbing it. If you need, if you want to note it down, you can note it down in your copies. All right. Now what is the center of rotation? If it's 2 comma 2 not equal, basically what I am checking here is if it's 2 comma 2, then distance of this point and its reflected rotated point, it should be same from the center of rotation, since in this case it is not same. So 1 2 1 2, that is your center of rotation, which you must get from your construction work, right? So center of rotation is 1 comma 1. That is your completion of first part. In the second part, triangle B is mapped onto triangle C by a translation vector -2 -3. It's a translation. Draw and label triangle C. So triangle B, this one, is translated to vector of -2 -3. So you need to draw the triangle C. For that part, I give you the time of 2 minutes. So start. All right. So it says the translation vector is -2 -3. -2 on the x-axis left side and -3 y side. So let's suppose that is your point A. If I move it -2, that means 1, 2, and if I move it -3, it means 1, 2, 3. So that is your point A dash. From A to this point, let's say this is y. We have 1, 2 and 3, so this will be same, 1, 2 and 3, so that is y dash, and B is here. So that is your triangle C after the translation. Moving on to the next part. Triangle A is mapped onto triangle D by a reflection in the line y equals to x. Draw and label triangle D. So firstly you need to draw the line y equals to x on your figure, and then you need to reflect triangle A. Alright. So for that reflection part, I give you the time of 2.5 minutes. First, draw the line and then start reflection. So your time starts now. Alright. So we need to reflect triangle A, but before that I need to plot line y equals to x. So that is your line y equals to x. If you reflect triangle A from that line, so this point should be here, this point should be here, and this one, the coordinates of this point is 2, 6. So after reflection it will be 6, 2. So this is your triangle D after the reflection of A across the line y equals to x. Triangle A is geometrically similar to triangle A and its longest side is 12. Calculate the area. Alright. Geometrically similar means A1 over A2 is equals to L1 over L2 whole square. So you need to apply this formula. You have the length of triangle A, you have the length of triangle E and its longest side. Make sure that you are picking the right side. So first write by yourself. The time for this question is 2.5 minutes. First try it by yourself and then I will explain. Start. Alright. Before that, I can find the area of triangle A, and if I do it right here, so I'll say that area of triangle A is equals to 1 upon 2 base into height. What is the base? It's 3 units, right? And height is simply 1 unit. So area is 3 divided by 2. The longest side is 3. Keep in mind. Now, when I apply the things here, so area is 3 divided by 2 and longest side is 3. The longest side of triangle E is 12 and the area is unknown. So I made my equation here. Now I can simplify it. 3 over 2 divided by A is equals to 3 ones are 3, 3 fours are 12, that is equals to 1 upon 16. So you can say that 3 over 2 times 16 equals to A. I just cross multiply the equation. And A is equals to 8, 3s are 24 centimeters square. That should be your unit.